Hello, May class, and welcome to your next maths lesson. So in the previous lesson, we were looking at timesing together three numbers, and we looked at the associative law of being able to move numbers around in a question, but it all comes down to the same answer. Sorry. So today we are moving on to look at factor pairs. So I'm just going to share my screen with you now. To start the lesson off, however, we're going to start with our arithmetic. So please make sure you have a piece of paper and a pencil with you. If you haven't, pause the video now and go and get that, and then come back and join us. So the arithmetic today is looking at our 12 times table. So I'm going to read through the questions. There are 10 questions as usual, and please make sure to write down your answers. So the first question is 4 times 12. Then we have 3 times 12, 9 times 12, 10 times 12, 0 times 12, 8 times 12, 2 times 12, 11 times 12, 6 times 12, and 7 times 12. Make sure that you have all the answers written down and keep track of them, because in the live lessons we are going over all the answers to your arithmetic. As mentioned before, we are going to be looking at factor pairs today. Now, factor pairs are numbers that can be timed together to get an answer. So to successfully get this lesson today, we are going to know what a factor is. I know that a factor is a number that multiplies by another number to make a product, which we discussed in a previous lesson. A product is the answer to a times table question, a multiplication question. So for example, 3 times 5 is 15. So 3 and 5 are factors of 15. So 15 is our product, the answer to our multiplication question, and 3 times 5 are the factors, because if we times them together, we get an answer. So I can also use equipment to work out our factor pairs for a number. The second LO is obviously, can I ask for help if I need it? And this often you can do on Tapestry. If there's an issue, please make sure to put it in the comment, and we can try and help as best we can. I will also be answering questions during the live lessons. So anything that you have an issue with or something you are struggling with, make sure to keep hold of that question and we will look at it during the live lessons. Okay, so starting us off, which factor pairs for 16 do these arrays show? So already before we start, we can see that the product, whatever it is going to equal 16. 16 is the answer. I need to find the factors that go into this. And remember, the array is the way in which our counters are organized. So this one, I can see that there is one row of counters. Get my eraser. One row of counters, and if we count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there is one row of 16 counters. So our factors there would be 1 times by 16. So the number 1 and 16 are factors of 16. So bearing in mind, we are still looking for factors of 16, but this one we can see has been split into 2 rows. So if I count one of those rows, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So I've got one row of 8 and then one row of 8, which means I've got 2 rows of 8. So 2 times by 8 will give me 16. So the factors that I have from that array would be 2 and 8, because 2 times by 8 will give me 16. The next one, if we have a look, there are 4 rows and there are 4 columns, which means I have 4 rows of 4. So the factor pairs there would be 4 times 4. So my factors of 16 that we have worked out here would be 1 and 16, 2 and 8, and 4 and 4. I want you to give it a think. Are there any other factors of 16 other than 1, 2, 4, and 8 and 16? How can you prove that you have found them all? So give that one a think as an extension. Are there any others that could equal 16? Okay. Here is a factor spider. So you can see it looks like a spider. So a factor spider for the number 18. So these are going to be factors of 18 that we have. So if we look at the first one, we've got 1 and 18. So 1 times by 18 would give me 18. So 1 and 18 are factors of 18. 2 times by 9 would give me 18. So the factors that we have there then are 2 and 9. We have 3 and 6, because 3 times 6 gives me 18. If we look at the next one, we have factors for the spider, for a factor spider for the number 20. The 21 would have 1 and 20, 2 and 10, 4 and 5. Now you may say to me, well, what about having 5 and 4? Because 5 times 4 will give me 20, and 4 times 5 will give me 20. But you'll start finding that as soon as we've used all the numbers, we can see that we've got all the numbers we need. So we've got 4 and 5. We have 2 and 10. We have 1 and 20. We don't need to say 20 and 1, 10 and 2, 5 and 4, because we've already got those numbers, because we know that either way, so 4 times 5 is 20, the same as 5 times 4 is 20. Okay, so that would be what it looks like. So I'd like you now to pause the video and write in a factor spider for the numbers 11 and 14 and 26. My suggestion to you would be to start with ones that you know. So for example, 1 and 11. See if there's any more factors that you can think of before you start repeating numbers. So start with 1 times 14. So for example, 1 and 14. Could we go 2? Could we go 3? Could we go 4? Let's see how many factors you come up with. But my suggestion would be the one you start with 1 times that number, and that will be factors of the number that you are given. So pause the video now and complete these 3 factor spiders. Once you have done that, we will move on to the next one of looking at completing the missing numbers. So again, we're going to be looking at factors. So the number 40, I want you to think for a second. We've got the number 40, and what are the factors of 40? So pause the video now and think to yourself, what factors of 40 can I have? And how many factors are there in total? So give that a think. Then, once we have done that, I want you to write down the factors of 40, and then we will look at our factor pairs. So I'm going to pause the video now and do that, and then we will go through the answers. Right, so hopefully you got the answers to this question. It may have been easier for you to start with working out what the factor pairs were and then going to the total number for how many factors there were. So if we were working it out, the number factor has, the number 40 has 8 factors. And the factors of the number 40 are the following. It's 1 and 2, 4, 5, 8, 10, 20, and 40. So I can see for you 1 times 40 is 40, 2 times 20 is 40, 4 times 10 is 40, 5 times 8 is 40. And then you would start finding that if we were going up with our numbers, the numbers would just be in reverse. So 8 times 5, 10 times 4, 20 times 2, 40 times by 1. Okay. So we have got all the factors that we need when we are timesing by 40. So our factor pairs would be 1 times 40, 2 times 20, 4 times 10, and 5 times 8. Again, I want you to have a think of how did you know to stop when hunting for factors? What made you think, okay, I think I've got enough now? We have got all the factors that we need. Right. I would also like you to look at finding the factors for the following numbers. So we've got the factors of 35, the factors of 49, the factors of 52, the factors of 46, and the factors of 60. So pause the video now and write down the factors for A, B, C, D, and E. Okay, so let's go through our answers. The factors of 35 are as follows. They're 1, 5, 7, and 35. So 1 times 35 is 35. 5 times 7 is 35. And then we would start realizing that then it would be the other way around. So 7 times 5 is 35. And there's nothing else until we get to 35 times by 1. The factors of 49 are as follows. 1, 7, and 49. Because 1 times 49 is 49. And then the only other factor we have is 7, because 7 times by 7 is 49. There is no other number that you can times 7 by. So I don't need to write 7 twice. I only have to write it once because it is the factor. You times 7 by itself and you get 49. The factors of 52 are 1, 2, 4, 13, 26, and 52. We would get 1 and 52, 2 and 26, 4 and 13. The factors of 46 are 1, 2, 23, and 46. So your factor pairs would be 1 and 46, 2 and 23. And then the factors of 60, we have quite a few because A, it's quite a big number. It's also an even number, which makes it a bit easier to find factor pairs. So 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and 6 and 10. Those are the factor pairs of those products or those answers to the multiplication questions. So your independent work today is going to be looking at factor pairs. So what numbers multiplied together give you a product? I will read through the questions with you. So Alex is making arrays using counters. What calculation is represented? Sorry. Right. Alex is making arrays using counters. What calculation is represented in each array? So the first one, you would need to count the row of red counters, and then you would see it would be 1 times by something. Then you would have the blue arrays and then the yellow arrays. So each one is going to have 2 factors that give you a product, which is the total amount of counters that you have. So using your answer for part A, help you write down the factors of 18. And I would like you to write them as factor pairs. So it would be 1 times by something. Right, the next question says, complete the factor bugs for 45 and 64. So just like we've looked at the factor spiders in the previous one, you will finish the factor bugs that have been given to you there. So the product of your answer, or the answer of your multiplication question, should be 45. They've given you the first one. They've said 1 and 45. So then there's some more. So keep going with that. The next factor bug is 64. So it has given you the first one. It has said 1 and 64. They've also given you one at the bottom there where they said one of the factors is 4. So what would the other side be if you have 4 times by something would give you 64? So I want you to give that a think. Then question 3 says, find all the factor pairs for the number 72. And I'm also happy for you to use the make your own factor bug to help you with that if you need. So write down the factor pairs. And then the last question says, class 4B is having a sports day. There are 36 children in the class. The children need to be in equal groups. What group sizes are possible? So you have 36 children that need to be in equal groups. So the groups need to be equal sizes. What group sizes are possible? So you would need to make sure that you knew your factor pairs of 36. So for example, I will give you the first one. You could have one group of 36 children. Could we have 2 groups? How many children would be in each group? Could we have 3? Could we have 4? So I would like you to give it a think, and how many groups with equal amounts of children could you make with 36 children? Please make sure that you are uploading your work onto Tapestry and sharing it with us. Any issues you have or misconceptions or things you don't understand, you are welcome to write them down and we will talk about them in our live lesson. If you aren't able to join the live lesson, I will answer some of those questions at the beginning of the next maths lesson before we start, just like we did at the beginning of this lesson. So yes.